Crawford. I'm one of the primary science facilitators for Science Spark, working in the South East region for Education Queensland. And this morning I'm going to be doing some stuff with you to help support the Year 4 QCAT. So this year the QCAT is focusing around erosion. So we're going to be doing an investigation of erosion and how it happens and how we can measure erosion, how we can gather evidence that erosion is occurring. So in order to do this investigation this morning, we're going to sort of step it through the way I would do it with a group of students in our cluster. So we would begin with what we call a general question, and you can see it up here on the whiteboard. What can change the amount of erosion that is happening? Then we would get the students to give us some ideas, you know, where erosion might be happening, what can make a difference to it. Understanding, of course, that erosion is particles being moved away by the processes of wind, water or gravity. So the students would probably come up with ideas like, if we're talking about water, the amount of water or the amount of wind. Another thing that might make a difference is the type of ground that we're talking about. Is it hard soil? Is it loose soil? Is there other stuff in it? That, of course, might lead them to think about vegetation. All right? Is there any plants there that's holding all of the stuff together? Another thing that might make a difference is how, if we're talking about water, how the water hits that surface. Is it falling down gently, or is it just, you know, gushing down over it? And then the angle of the slope might actually make a difference. Now, students might not use the word angle, they might use the word steepness. All right, but we understand that they're talking about angle, and if we're talking about a slope, it could also be the height of the slope. So how much time does the water have travelling down that slope to speed up to gather more energy? So once the students have identified all of these factors that might affect how much erosion occurs in an area, then we need to take this and turn it into a focus question. So I say to the students, this is a perfectly good question in itself, but it's not a good investigation question. It's not a good question for hanging a scientific investigation on. A scientific investigation question or a focus question should identify very clearly what it is that you want to do and what it is that you want to measure or observe. So we're trying to get the kids into the idea of, I will develop the skill of framing my question in this way. And by doing this, it supports the students in a lot of the stuff that they do afterwards, in predicting, in identifying their variables, and at the end, making an evidence-based claim. And evidence-based claims is a big part of the 2012 QCAT. So for this investigation, we are actually going to focus on this one, the angle of the slope. Does that make a difference to how much erosion might occur in an area? Alright, so now that we've got our general question, we're going to turn it into a focus question. I've had to clear some space off here, but remember, our general question was, what can change the amount of erosion? Now, we said for our investigation, this is what we're going to focus on. This is what we're going to change. So now I'm getting the students to copy from the whiteboard. They haven't copied all of this stuff then. This is just our musings on the whiteboard, getting ideas together. But now we're getting them to write the actual focus question, which is going to be, can changing the angle of slope, and I'm going to change colours here, you'll see why later, change the amount of is now the focus question. It identifies two very important things for our investigation. Firstly, what am I going to do? What am I going to change? I am going to change the angle of the slope that the water is running across. What am I going to measure? I'm going to measure the amount of erosion that is occurring. So how much soil and dirt is moved from one place to another. Alright, so now I'm going to start filling in my variables grid. Now, a variable is anything that we can change that might affect the outcome of our investigation. There is only one thing that I am going to change for my investigation, which is identified up here, and you see I've written it in red so the students can look at it. So I'd be saying to them, look at the first part of our question. What is it that I'm going to change? And it's written right there, can changing the angle of the slope. So then the students are putting up their hand and they're telling me, well, Mr. Crawford, you're changing the angle of the slope. Right? So that goes in the top left-hand corner of our variables grid. In the variables grid that our cluster uses, we actually put these words in here so that the students know what's going on. Now, the next thing is, what am I going to measure or observe? Now, you can see here, we've written, can changing the angle of the slope change the amount of erosion? So we're looking at the amount of erosion. Now, some students get confused because we're saying to them, we only change one thing, but really, it looks like we're changing two. This thing that we're changing is called the independent variable. So the angle of the slope is the independent variable. That is the thing that I change. The second one, the thing that we measure or observe, this is called the dependent variable. And what I say to the kids is, this is what changes depending on what I do. So I'm not actually changing this. I'm changing this. And this is changing because of what I've done. So I am going to measure or observe, and I'll put this one in black using my colour code, the amount of erosion. In other words, exactly how much material is moved from one place to another by the action of the water. Now, to finish our variables grid, we've got to identify all of the things that we have to keep the same. But this is the great part. The kids have already done it. All of these things that they told us could affect the amount of erosion, these are the things that we need to keep the same. So you can just be saying to your students, all of these other things, that's what you've got to write down. This one is gone. We've used that. Just get all of these other factors, fill them in the boxes marked same. Those are the things that we have to control. And sometimes you use all of the boxes, and sometimes you don't. Okay, so now we've got our focus question, we've identified our variables. The next thing we want to do with the students is get them to make a prediction. So our predictions are usually framed around three words, if, then, because. So if I do this, then this will happen because of this. So for year fours, I'm very happy to put the prediction up there for them. But what I'm constantly saying to them is that your prediction is how you think this question will be answered. Some students, without that guidance, would write a prediction like this. If I run water over a slope, then dirt will get pushed down to the bottom because the water will wash it there. Now that might be a perfectly valid prediction, but it's not answering that question. So we need to be saying to the students, the prediction you have is how you think this question will be answered. Of course, this is often a problem because kids don't want to be wrong. We need to be saying to them, there's no A in science for getting your prediction right every time. Scientists make wrong predictions all of the time. Getting your predictions wrong is one of the ways that we learn, which is why after 15 years I'm such an amazing husband. So for this investigation, what I've put up here is if I change the angle of the slope, relating my prediction back to my question, colour coding that for the students, then, and the students will be copying this down, there won't be a change in the amount of erosion. So they copy down the whole first part, then in the second part they choose. Do they think changing the angle of the slope, making it higher or lower, will have an effect on the amount of the erosion? The last part, because I don't fill that in, because this is where we want the students to identify their thinking. It is not necessarily a scientific explanation. It is simply the students articulating what they think is going on.